Welcome to The Explainer. Okay, let's kick things off by imagining you've ordered lunch on Zomato during peak city traffic. Normally, one delivery driver picks up your order and takes a single route. If that road gets jammed, well, we all wait, including that poor driver. Now imagine if your order was magically split across multiple riders, taking multiple routes simultaneously. If one road blocks, the system instantly reroutes through another lane, and your lunch still arrives piping hot and perfectly on time. That brilliant, dynamic routing is exactly what's happening right now in the world of artificial intelligence. Modern AI factories have scaled up to the point where they have more than 100,000 graphics processing units, or GPUs, trying to talk to each other at the exact same time. And the absolute biggest constraint they face? Network traffic. If just one single network link fails, 100,000 incredibly expensive processors sit idle waiting for data, just like you waiting for that delayed lunch. Because of this, the tech industry is desperately trying to shift away from those fragile, easily jammed single delivery routes. They're moving toward an intelligent multipath city grid that can instantly reroute traffic around accidents. So, here's our game plan for today. We're going to look at the AI traffic jam, a revolutionary fix called the MRC protocol, how it's totally rethinking the network, why fierce rivals actually teamed up, and finally, what this all means for you. All right, part 1. The AI traffic jam and the straggler effect. When AI training scales up to these massive 100,000 processor supercomputers, the stakes get, frankly, astronomical. To understand the panic around network traffic, you really just have to look at the bill. Training a frontier AI model currently burns between $20 and $30 million a week. And that's just in raw compute costs. Literally, every single second counts. And at this crazy scale, hardware failures aren't just rare flukes, they're a mathematical certainty. Even with a tiny daily node failure rate of just 0.5%, in a massive GPU cluster, you're looking at about 500 GPUs going completely dark every 24 hours. This constant failure triggers what infrastructure operators call the straggler effect. See, AI training is incredibly synchronized, so if even one tiny data transfer drops, maybe a network link flapped or a switch got overloaded, the entire multi-million-dollar operation basically grinds to a halt. Thousands of GPUs literally just sit there, doing absolutely nothing, waiting for the slowest node to catch up. Suddenly, the network is the ultimate bottleneck, not the chips. Okay, moving to part 2. Enter the MRC protocol, or Multipath Reliable Connection. To stop this huge financial bleed, OpenAI and a few other tech giants introduced a groundbreaking solution called MRC, and it requires a massive mindset shift. For years, networks were built assuming things would, mostly work fine. MRC flips that entirely. It treats hardware failures, like dropped packets or a switch rebooting, as a completely normal, everyday operating condition. So how does it pull this off? In 3 steps. Instead of forcing an entire data flow down one single path, MRC sprays the individual packets across hundreds of network paths all at the same time. It uses something called static SRv6 routing. Think of it like a set of super strict pre-programmed GPS directions to confidently bypass congestion. And the craziest part? It actually detects and heals around failed links in mere microseconds. That is literally the difference between a training run going buttery smooth or freezing entirely. Which brings us to part 3, rethinking the network and the big hardware pivot. This software protocol is actually so powerful, it is physically changing the hardware in the data center. Historically, ultra-large AI clusters relied on a really tightly coupled proprietary standard called InfiniBand, which needs super complex switch setups. But MRC is aggressively pushing standard Ethernet back into the elite AI core, connecting over 13,100 GPUs using just a simple 2-tier Ethernet structure. Fewer switch tiers mean lower latency, less power, and a drastically reduced bill. And the real secret sauce making this 2-tier setup so incredibly stable is that static SRv6 routing. At a massive scale, having switches dynamically try to guess where to reroute traffic just creates unpredictable chaos. By using static routing, the exact path is encoded directly into the data packet. It completely removes the guesswork, gives engineers instant, deterministic feedback on network health, and makes these giant million-link AI clusters so much easier to debug and stabilize. All right, part 4, why fierce rivals teamed up. An unprecedented alliance. Now, this might actually be the most surprising aspect of the whole story. The unprecedented corporate alliance that made this happen. Just look at these names: OpenAI, Microsoft, NVIDIA, AMD, Intel, and Broadcom. These are companies normally locked in brutal, cutthroat wars for AI supremacy. Yet, they teamed up to build MRC because they finally realized that the ultimate bottleneck for AI is the physical wiring. I mean, it doesn't matter who makes the absolute fastest chip if the network keeps crashing, right? Mark Handley, the networking lead over at OpenAI, really hit the nail on the head here. The scale has gotten so large that fragmentation actually hurts everyone. By contributing MRC as an open standard to the Open Compute project, the whole industry avoids these siloed proprietary systems. A shared baseline lifts all boats, so everyone gets to scale faster and cheaper. And finally, part 5, what it means for you, the everyday impact. So what is in it for the common people? Why should you care about some highly technical data center upgrade? Well, remember that $30 million weekly training bill we talked about? If MRC improves efficiency by just 10%, that saves roughly $3 million a week in wasted computing power. Companies are taking those massive savings and reinvesting them directly into faster release schedules and vastly smarter capabilities. And that translates directly to cheaper, more powerful AI access for all of us. Plus, because this technology is completely open source, the big players aren't the only ones winning here. Pretty soon, this will be the default setup on AWS, Google Cloud, Azure, the whole shebang. So those agile little startups building your favorite everyday productivity tools, dating apps, or creative platforms, they automatically inherit these massive speed and cost efficiencies. It literally raises the floor for the entire software ecosystem. As we wrap up this explainer, I want to leave you with one final thrilling thought. For years, the physical wiring of these supercomputers has basically been acting like a giant handbrake on the true potential of artificial intelligence. If this intelligent city grid clears the AI traffic jam for good, and the network is suddenly no longer the limit, what incredible, life-changing tools are these AI factories going to build next? Thanks for learning with me today.